coast of US, and it's 11 p.m. in Australia, where our next presenter resides. And Arash Aghlara is the CEO and founder of a popular decision intelligence platform known as FlexRule. And he also very active expert in decision intelligence in general, and you can read a lot of very interesting posts made by him regularly at LinkedIn. And today he will share extremely important topic of continuous decision. And without further delay, Arash, please go ahead.
Absolutely. Thank you very much, Jacob, for the kind introduction. So I know a lot of presentations we've seen so far were focused about LLM and Gen AI and agentic AI and all of these shiny objects in AI, which at some point, as Dennis mentioned, it become norms. But I promise this is not so much about those talks. And I want to talk a little bit about how we got to this position of where we are at this point of time in terms of decision modeling, what problem does it solve and still solving, and the consequential effect of the way we approach it, and what's the next step moving forward in involving more different types of actors in terms of decision making and allowing them to be more engaged in the real world that we make decisions in organizations. Now, with that, most of us intend to use data as part of our data and analytics practice to make better business decisions, yet the stats shows we don't actually do it. We often end up using data to justify decisions we've already made. Now, if we want to look back and see exactly what is the reason behind it, and this is not like an old stat for 10 years ago, it's for 2023 from Oracle. And if we want to go back and have a look at the reasons behind this, it's essentially very deep into deploying the process called action framework, which tend to create the actionable insight from the data organizations hold. So we've been deploying this actionable framework by start acquiring the data, then we turn data into information to make sense of it. We generate insights from the information, then we apply those insights to take actions and create outcomes. Essentially, seems very linear, and we approach it very linear. And that's the classic process of how organizations have used data and analytics to make better business decisions. And we saw just this that. One of the reasons we see so many of us not really using data to make better business decisions is because this action framework itself creates a barrier. On top of that, it actually pushes us down the path of confirmation bias. In other words, we end up using data information inside in a way that we want to justify the decisions we already made. And that's the confirmation bias, the defect of human mind, essentially. But before we're going to go to address how we solve this challenge already using decision intelligence and focus on the unintended consequences of this solution, let us have a bit of level setting on what a decision is, because I know many of our practitioners in this DecisionCAMP have very similar definition of decisions. But outside of this set of practitioners, I bet there are many different definitions on what a decision is. Now, let's have a level set. So a decision is a commitment to a course of actions to shape the final judgment and create outcomes based on data, information, rules, computation logic. Now, with having this definition mind, let's go back and have a look at the action framework again. So as I mentioned, deploying this traditional action framework into organizations create a barrier for decision making. We've seen that using traditional action framework often creates a mismatch expectations. When we talk to many of our prospects and clients, we see the insight that the data and teams produce don't match what business needs to turn into a real action. And that is not only our experience, this is what business stakeholders are also talking about broadly. And that's why a lot of business stakeholders feels there is a gap between what they need and what they get from the data and IT team. Although data and IT teams strongly believe they have the best data, they have the best algorithm can someone possibly train, and then the other side of the business, the other side of the wall, still can't use to provide can't use the provided artifacts for their decision making. As the result, data and IT team going back and they do exactly what they've been doing and creates more data, more analytical artifacts, whatever that is, report, dashboard, algorithm, anything that they possibly can. Still doesn't solve this specific barrier and doesn't cross that barrier. And one of the things that we recently seen, again, similar report, the same report, in fact, is that is not only our experience in talking to prospect and clients, it's more broader. 77% of business execs sees that data analytics artifacts are not relevant to their decision they need to make. And this is a significant loss of effort in organizations, as we can see. Now, that is really back in 2023. And with the emergence of, I promise not to name it, but AI in terms of Gen AI, LLM, agentic AI, what IT and data team is trying to do to eliminate this barrier is throw AI, Gen AI and LLM to this problem and hope that it's going to solve this problem and takes the barrier away. But also, we know for a fact that based on the reports, that wasn't really the expected outcome. And it's kind of very hard to say that's been successful with the recent reports. Not only the MIT, there are other reports that shows that didn't really work. Now, as the practitioners of decision intelligence, this is where it gets interesting, and we've been doing this for decades. So in applying the decision intelligence, as we mostly agree, at least most of us, that solve this challenge by starting doing the decision modeling in specific workflows. So the way it works is we pick a workflow, we understand their decisions, we model the decisions that improves the outcome for those specific workflows. And then we go backward to upstream. That means understanding what inside data information the decision needs. And then we go downstream, identifying the actions required that to create those, based on those decisions, what actions do we need to create? So the decisions becomes the focal point, the decision model. In practice, that's all theoretical, but in practice, to make sure this happens and truly we close that gap and we remove that barrier using decision modeling, applying decision modeling, we need to narrow down. We have to go into the specific workflows that use data and analytics and really understand how they operate. That means we need to ensure that we go deep into the business, understand the nuances of the business, and as the result, to remove that barrier across many different workflows, we create hundreds and maybe thousands of these decision models that supports those specific workflows across organizations. Of course, Now, because we are addressing the barrier in a narrow workflow by applying decision intelligence, then these decisions are siloed. They are specific to those workflows. And this is what the problem happens. Now, because they're siloed, there is no end-to-end context. They don't know their influences on each other. They can adapt to previous decisions and the future paths. Therefore, they're not also optimized. This creates a situation that what we call is disconnected decision experience, because they lack the end-to-end context for broader picture. The end recipient of those decision outcomes won't be really happy because it doesn't reflect the environment they're living in. Even though we make those decisions based on explicitly modeled from those specific workflows, it's not truly connected to the real world. That means the recipient of that decision feels still the outcome of the decision is irrelevant, similar to the data analytics problem that the business executive thought the artifacts are irrelevant in that context. The reason for that is because decisions influence other decisions, and when we are narrowed down to a specific workflow, we don't have that full picture. Therefore, we can't really know the outcome of the other decisions which influence these decisions, and then the circumstances of that particular recipient of decision has changed because of the previous decisions. Now this decision at this moment of time, the outcome of that, it becomes irrelevant. Now this is a problem that what I want to solve in this part of conversation. Now, how do we solve this problem? So one might say, okay, we've been doing process modeling and workflow and orchestration. If we do end-to-end orchestration and workflow, this problem will be solved because they provide end-to-end context. Well, the problem is they don't allow a flexible responses to unexpected conditions and situations. We're talking about end-to-end workflow and processes. They are prescriptive. You really need to know what step and then model them. More often than not, if the journey of the recipient of the decision are not really predictable and linear, you can't really use process modeling. It becomes something that you see in the picture. And additionally, even if we manage to solve the end-to-end context with the end-to-end orchestration, they lack adaptive behavior and optimization across the journey and in the moment of the decision. So the end-to-end orchestration and workflow does not really solve this problem because of these situations I explained. The predictability of the workflow that we need to model the next steps, the journey of the recipient of the decision generally are not predictable and linear. Adaptive behavior for changing circumstances is not there, and unexpected conditions and situations cannot really be addressed in terms of the process model. Now, with having this in mind, I want to suggest something what we call continuous decision model that addresses the lack of end-to-end context where execution of set of decisions spans across the time and influence each other, while ensures the decisions are optimized in the moment and for the long-term goal. Now, what I'm suggesting here is not really change. It's not just a graphical change of how we model business decision, workflow and processes. It is a continuous decision model, and it closes the gap left by traditional models, but it stitches decisions together over time into a living continuous flow of context. So continuous decision model fundamentally changes how decisions are structured, triggered, and optimized over time with two fundamental concepts. So if we look at the traditional approach in process model workflow, we need to have those steps one after another. If we don't know what the next step is, we can't really do anything. Now, continuous decision model flips this approach. What it is important in this kind of model is two things. One is called stage, another is called best decision. So those hexagon shape you see on the screen are stage, and the best decision sits inside those stage. And a hexagon shape that represents the stage. Stage is a specific point in time where the subject, whatever that is, customer, claim, case, is currently located. Stage is a decisionable moment, right? So in this model, a stage defines where we are, and best decision defines what to do. Given where the actor in this particular case can be anything, it is a multi-actor modeling. So the actor can be a human, can be a system, can be a bot, can be an agent, whatever that is. This enables collaboration between all of them because it's an event-driven model. Now, transition from one stage to another happens based on an event. Given where the actor is, an event happens, it transitions from one stage to another. It's a long-running model. That means it does not necessarily even finish. It may go back as long as it continues. And the CDM receives, when it receives the signal, it can progress from one stage to another if the condition of that stage is satisfied. That means we can guarantee the best outcome or acceptable outcome to leave that stage to the next one. This is where it gets interesting because now, as it is a multi-actor inputs, human, system, bot, AI agent, etc. So we can let the AI agent does its job, and based on the outcome, we can say whether that outcome is satisfied or not, so we can transition from one stage to another. So that enables that collaboration and allowing autonomous system essentially to collaborate in decision making within organizations. Then CDM also orchestrates between all the decisions that should happen across the time, providing the end-to-end context and the history of the executed decision, also the information that we potentially have for the future path of the several decisions in front of us. And what that means is CDM is a sequential decision theory inspired architecture. Make a decision not just for the current state, the best decision, but in a way that it leads to the best long-term outcome for the whole journey across sequences of the decisions that influences each other. Since at any stage, we know all the previous stages and potentially the next stages, we can optimize for the long-term outcome as well. So it's not only the decision that is happening inside this stage is optimized, now because we have the backward and forward view of the overall journey or overall decision, that the set of decisions we want to execute, this enables us to optimize for the long term using multiple different techniques that are available these days. Now, to give you one example, a practical example of what does it look like. So if we look at a customer journey in a market customer engagement scenario, Imagine you, as a customer, want to get a loan or whatever that intent of your engagement with the service provider or financial service or bank or whatever that is, right? Now, you can see at top of the screen, you go to different channels. You go to website, you go to call center, you open your email, you use app, you go chat, but you do different things in different stages of your engagement with the provider. Now, with the continuous decision model, you can actually map this whole journey, not based on the steps you go, based on the outcome that is expected as satisfactory for that stage. And this enables the long-running service as the continuous decision service to serve the specific decision at that particular stage. So in financial services, at any point of time, you will be eligible for many different decisions that they can execute. Which one of them gets priority? So are you in sales or mode, or are you in retention mode? Or do they push the product to you? Will influences you to not to be so much happy, so you leave them? Do they need to execute decisions related to the retention? So it really depends on this stage, and that's what this stage is representing, the decisionable moment for the best decision. Now, if you're moving from, for example, a call center to the next channel, which you go and you finish your call with the call center and you go back to the email, you should still have the consistent messages coming through. That's one, consistency. Also, now that you have had that conversation, what is the next best step for you to take to actually satisfy the objective of your engagement with the service provider? So the previous decision should have the influence on the next possible actions for you based on the decisions that they need to execute. So you can see kind of these sequences of the decision that influence each other, and you don't necessarily, as the modeler or author of this decision, care how you act for specific workflow. You care about the outcome of that workflow, which represents as the acceptable outcome in this stage, which is associated with something called best decision. Now, the best decision is the most contextually appropriate decision that can be made at specific stage for a specific actor, given everything we know at that particular moment. Now, in order to make that best decision, if we talk about, for example, again, financial services, at any point of time, there are like hundreds of different things they can do. But which one of them yields to a better outcome in that moment? And that's what the best decision is. The best decision is the most contextually appropriate decision that yields to the best outcome. Now, for instance, let me give you an example of the best decision. So there are multiple different techniques we can use for the best decision. One of the so we use composite AI technique. That means combining rules and predictive model and different reinforcement model and constraint programming, all of that to tell what are the most relevant outcome for a specific subject. Now, in order to explain that, this is like a very simplistic form of it, but let me go with that. So let's say you book an accommodation in Airbnb or hotel or wherever it is, right? Now, they can offer you multiple different nudges to make sure that you're happy and you come back to the accommodation again, right? Now, the first thing first, this is like a very similar approach in terms of how you started. You model business decision, and this is a best offer decision in this particular specific workflow we are talking, right? Now, they need to determine your status. Are you a VIP person? Are you a loyal customer? Are you returning? Are you new? So that is a rule-driven approach. Now, once they know the status of you as the guest, then they apply another set of rules to determine what are you eligible for. Now, imagine in your scenario, you will be eligible for multiple of these things. Now, which one they provide to make sure that has more acceptable rate and it makes you happy to come back. If you're a business traveler and you're staying there for a night to go to a meeting, you're not going to stay another 5 days. So giving you another 3 days free is not going to solve any of your happiness problem. Therefore, this is where the composite AI comes in. So an adaptive learning based on the feedback we received for similar clients, we can apply the reinforcement learning technique to calculate the probability of receiving a positive response from the offer we give you. And this is like the arbitration ranking between all the eligible offers that you're eligible for. So in this particular example, you can see a freebie package 2 nights free, late checkout. They are all available and you're all eligible for, you are eligible for all of them. But which one do you respond positive based on the feedback we receive? So in the continuous decision model, you can have intent and feedback and it closes the whole loop. We train the model behind the scene that now ranks the relevance of this offer based on the contextually relevant in that moment and it probability of freebie package 2 to be received more positively with you as an example is more higher. Therefore, they're more confident which nudges will work better. So that's one of the options in terms of the best decision. So best decision is in that moment, and then overall of sequences of the decision and influencing each other for the long term. Now, another approach for a best decision in composite AI is using operation research technique. In this specific example, we can have a constraint programming plug into one of those nodes, which it makes sure the best decision for the competing priority or whatever that scenario is actually is satisfied. When we're talking about the best, it has to be optimized, and that is one of the challenges we want to solve with the continuous decision. So optimize at the moment and optimize for overall goal. Now, a real case example of the best decision as part of the continuous decision. So to just quickly recap, because I talked about too many information, maybe new to many of us here. So a continuous decision model, this is how it looks like. Those hexagon shapes are stage. It's an event-driven and transitions from one stage to another stage based on an event. It is a multi-actor input. That means those events can be received with whatever, system actor or human actor or AI actor. So as long as the signal is received, it can validate it based on the best decision and it can move forward. Now, one of the example is in financial services. At any point of time, you're eligible for many different things. Now, in this particular case, we want to make sure it is part of the retention scenario, and we want to make sure the call center has the right conversation with the person behind the line to make sure they can reduce the churn as the overall goal of the journey of the engagement. So overall goal is reducing the churn. This specific decision is what is the best offer at this moment in time. Now you can see, for example, in this specific decision model with the decision table we have, we satisfy multiple criteria to find what are the eligibility of this particular person in terms of having the access to the fund or transferring the fund, or essentially what we want to do is we want to determine the best possible conversation in the call center. Now, after doing all the eligibility, still the agent at the call center might still find the client at the other side has 5 eligible conversation. Which one of them will be received more positively to yield better outcome for the customer and for the business? And that's where the arbitration ranking and probability comes into play, which then based on the history of the data we have, based on the potential stages in front of us and decisions that we already made, we can rank that saying, okay, make an investment switch is probably received more positively for this specific scenario at this specific time for this specific client. Now, to just recap about what we discussed. So continuous decision model makes the silo go away. It makes them connected best decisions, not just any decision. They're optimized in the moment. It shares the end-to-end context for all of these decisions. So it's contextual, end-to-end context. Adaptive learning by feedback. So the continuous decision model also enables the fully feedback cycle as part of the stages that it has. And it is optimized for the moment and the long-term goal. So it really eliminates that disconnected decision experience that we just talked about. And this is not just a reframe. This is a model, is innovative in how we brings together the connected, contextual, adaptive, and optimized decision. And because of the innovation involved, we managed to secure a patent for it. Now, based on the continuous decision model, now, because it's event-driven, that goes to the conversation I just had quickly with Alan before this presentation. So that enables the part of the problem, not all the problem we had with AI agents, allowing them to contribute in the best governed possible way in terms of the decision-making in our organizations as well. And that is essentially my last slide, and I am open to having conversation and answering any questions if anyone has.
Okay, great. Thank you, Arash. That's a very, very important points, going from disconnected decision experience to what you call continuous decision model. This is very practical things that many of us face when we do real world development. We have a question from Alex. Alex, you can clarify it because Arash partially answered.
Hi, good morning, good afternoon, and thank you for the presentation. As I was, I put in my questions early on, and I think you as you were going through it, I think you probably did go ahead and answer most of them, Arash. I did have a second question, but I don't want to hog up the time that we have for Q&A. So I will go after. I don't know. I see, Alan, you have your hand up, so I will give the floor to someone else. So it's back to you, Jacob.
Actually, your question was not answered 100%
Oh, it wasn't
because
answered 100%. Okay,
yeah,
so then maybe back
yeah,
back to
because
you, Ross. So
I
no,
like your
then let's see
question.
it's back on you. So then maybe I'll just I mean, it was really around the criteria that you're using to measure or define how the outcome is satisfied. So I was hearing bits and pieces of it, but maybe if you want to expand on it further to Jacob's point.
Yeah, Arash,
So, sorry, what was the question? I didn't quite
it
catch
was
it.
about criteria you
Okay.
use to measure or define out that outcome is satisfied. When
Okay,
you do.
definitely. So that goes to that goes to two levels in a stage of the continuous decision. So it's a sequence of the stages. One is at this point of time, what's the best decision we can make for this particular situation? And once we've made that decision, in order to leave that stage to the next stage, there is a criteria that needs to be satisfied. This satisfaction of the leaving of the stage is essentially driven with another decision model. Essentially, it's an outcome driven. And as we progress from one stage to another across many clients, imagine in a bank you have couple of million clients in different workflows. That enables you to capture the criteria and context of moving toward the next stage. So what is going to happen is, if the overall goal of this particular journey is to reducing a churn, that means once we have the collected data, some amount of data, depends on the actual accuracy that you want, we can optimize the outcome required for each decision. And that goes toward the techniques that we can use we borrowed essentially from sequential decision like Q-learning or reinforcement and so on and so forth. So the outcome of the decision, when I'm referring decision here, I mean the continuous decision. The outcome of the continuous decision, the objective of that is reducing the churn, and then individual KPI of those decisions will be optimized as we're collecting the data across many clients. Does that make sense?
I just would probably add one thing when you mention about optimal, finding best or optimal decision at every point. Let's look what yesterday was presented by, or the second day it was presented by Maynolf Selman about decisions made in under uncertainty, when instead of looking for optimal decision at certain point, we're looking for, like you just mentioned, overall decision. So it's not necessary to make optimal decision at every point of time, but it should be a good decision overall. So
Correct.
this is probably criteria.
That is a very interesting point, because sometimes they are in contradiction. You may have the best decision at the point of time, which is push product. But if the objective of the overall continuous decision model is to reduce the churn, and that push product is going to annoy the clients, they're going to leave. So the fact that we know the stages afterward is helping us to optimize what is the best criteria at this point of time. And that goes to the reward system and rewarding and the rest of the story.
Yeah, there are not a really 100% clear answer to this question. It always goes to particular situation and skills of people who do this modeling, and Maynolf gave very good examples of this. Alan, please continue. Alan?
Thank you. Yes. Right. Okay. Can I just? Well, first of all, I want to say I agree entirely with your initial statement in the presentation about the inadequacy of the data-driven model of decisioning, which I think is thankfully already going out of fashion. But it is important to point out that you can't actually design your decisions on the basis of a data flow. You have to base it on terms of what your objectives are as an organization. Can I just check something though in what you mean by this continuous decision model? Is it essentially event-driven decisioning you're talking about?
So it combines multiple things. It's event-driven and it is sequential decision, all in one model. So
whenever you make a decision, it is synchronous, stateless execution of a service of a complete decision model. Is that your how you're working?
No, so the continuous decision can be synchronous and can be async, but also more importantly, it's a long running, so it has a full context, durable context across all the stages. So it's the individual best decision within the context are stateless, but the overall journey and overall continuous decision is stateful, and it holds all the information across the journey.
Okay, I'll have to think about that. But anyway, I'd like to drill down into what you mean by best. Okay, that's the crucial thing here. I've always thought, to be honest, that this idea of the best next decision has always rankled with me, because I think it's a really simplistic idea that at any moment there's only one decision you can make, which is to choose between alternative courses of action. But I suppose that it could have the advantage in your sort of framework that you could use some sort of game theoretic approach to thinking about the various possible sequences that could follow. But I do think it restricts you in terms of the set of decisions you might be making in parallel at any moment. But more importantly, I'm concerned about the fact when you say the best decision at any moment, what do you mean? The best for the customer? The best for the apparent goal of this process? Because what we really want is to achieve results over the portfolio for the industry. So we're not actually interested in what is best for this customer. We're interested in the decisions we make over many cases, which will result in the best values of the KPIs that we want to achieve. And when you're thinking in that sort of world, you have to realize there are different KPIs which are of relevance to different business stakeholders, which may sometimes be contradictory. And we want to optimize over all of that. And we need to understand the causal influences between individual decisions and the resulting KPIs, and causal influences amongst KPIs, and it all gets horribly complicated. But it's certainly not a case of just picking one best decision out of the air at any moment in time.
Yes, you're absolutely right. And it gets more complicated than that, because sometimes the KPI of the executives are kind of in contradict, and they're fighting. Someone wants to sell more, someone wants to reduce the churn. Now, exactly. Now, the way the continuous decision model solves this is if the organization agrees that is the objective of the next quarter is to reduce what or increase what. Now, there are two optimization happening in the continuous decision model. One optimization happening across all the stages, that is the overall optimization for the final KPI. Now, the other optimization is happening individual within this stage at that moment in time. And as you mentioned, they might be in contradict. Therefore, if we think of the reward scenario, you might have a better reward if you just do the best decision, meaning we want to sell. But then that is in contradict if we know the alternative path of the journey, because now we have the future stages. We know exactly what alternative paths are in front of us. So then that best decision will be influenced by that alternative path in front of us. It's not necessarily, it might be best at this moment of time, but it may reduce the KPI or may decline the KPI overall. Therefore, there are two optimization happening. One is overall, one at the moment. And you're absolutely right.
So you imagine adopting some sort of decision analytic approach, looking at all various possible expected outcomes and trying to maximize over those?
Yes, similar. Well, the Q learning and Q table might be a simplistic form of that at the journey level, and then the constraint programming and reinforcement learning for increasing the reward within the stage, and then you can kind of optimize that for the overall, as you have millions and millions of the journeys, so you can see what ultimate path leads to a overall better KPI at the long term or within the short term execution.
How do you actually? I'm sorry, JP.
No, go ahead. No, we have time. We have time. It's important.
Okay.
Go ahead.
So how do you formalize the expression of the objectives?
With the DecisionLang, so if I can show you a couple of slides back. So this is, for example, a set of constraints you specify, and then you can say, we want to minimize this. This is for the best decision within the moment, not the overall objective of the journey. So there are expressions allowing you to similarly do for the overall KPI of the whole continuous decision and within the specific decision itself.
I see.
Okay. Yeah, this is a huge problem what professor from optimization, Maynard Selman, mentioned about multi-objective optimization.
Yes.
And it's that's what you're pointing to, right? And there are two other interesting questions if you look on the chat, but you already pronounced very important words. You said that each separate decision is stateless, but overall decision is stateful. And so it immediately brings a concept of state machines, and both questions from Alex and from Denis deal with state machines. So you can read. Can you read it, or you can see in chat?
I'm trying to find the question in the chat. To be honest, I don't see any.
Okay.
Can you read that for me?
Yeah, yes. I can tell you. Just Alex is curious about your continuous decision modeling, and it focuses on best path outcome, but does take into account the path in the process in general. So it certainly should deal with state machines, right?
Yeah.
And
yeah.
Denis tells you about the CMMN standard already has state machines, and it's included in the event condition action semantics.
So sorry, Jacob, let me expand a little bit more.
Yeah, go ahead.
Yeah, so it's really more about, I am trying to understand a bit how are you identifying divergent paths in the business process? So this is the ideal view of how the process should happen, and that's great, but how are you actually taking into account where in the process do behavior outcomes different from the expectations, and baking that back to this ongoing continuous model? And so where things are different in the actual real human world. You got people, you got machines, you've got human behavior. So things are different from what you're putting here in the model, and so baking that back in. So I'm kind of curious, where does that happen?
So that's a very good point. And the whole purpose of the continuous decision is to flip the focal point from the alternative paths in the process and conditions and gates and different steps to we don't care about any of that. We care about the outcome that process achieves. Now, as I mentioned, because now we don't care about those steps, but we care about the overall KPI of the whole continuous decision model. Therefore, different alternative path that goes, the outcome will be different, slightly better, slightly worse, whatever that is. Then we can, based on the millions of the processes Alan mentioned, going through this continuous model, then we know for this particular stage down the path with this outcome, the overall goal was better. So the whole idea is we don't necessarily need to care about, well, we care, but at another level and another view, the alternative path of the process goes down left or right. The outcome that we care is within this scope. So is it acceptable? And as we receive more of that, we can optimize for the individual outcome and for the actual overall KPI of the whole model.
So wait, I just want to make sure I understood this. So you're not, your perspective is not to take into account the real world, or did I hear that right?
No, you take into the account. So when you mention real world, give me one example. I can answer with the real world example.
Yeah, so let's say that the outcome is to, I don't know, increase, I don't know, machine output, boost productivity, I don't know, whatever you want to talk. But at the end of the day, you might have that in the real world that is not, you're not hitting, I don't know, you may just have that the at the shop floor, you may have that there is a that is not happening, right? There might be team members that for whatever reason they're focused more on producing another type of product, and therefore your productivity is actually decreasing. I mean, I'm just thinking about this on the fly. So it's really helpful to understand, you know, where in the process are their behavior or outcomes that are different from expectations. And that could be because maybe they're incentivized to focus because their bonuses are attached to something else, right?
Correct.
Right. So, but my point being, you would never know that unless you're actually taking into account what's happening in the real world, or one of the machines is broken. So therefore it doesn't matter, you know, what the end goal is, if at the end of the day in the real world, you know, one of the plant manufacturing machines is broken, right? Or, you know, one of your I don't know, one of your one of the people from I don't know, someone in the warehouse, you know, the truck is late or whatever it may be. It's just the real world, you know. So that's kind of what I'm trying to say. Yeah.
Interruptions. And that's a very interesting example. So I didn't go through all the details of continuous decision. So one of the benefit of doing the continuous decision is you can account for interruption and exceptions and unexpected behavior into the uncertainty. So the examples you mentioned falls into that account. So one of those stages that you see in the continuous decision can represent unexpected machine failure, or someone is sick, or whatever it is. And then the journey can pivot toward that unexpected behavior through the new stage. And as you go through those stages multiple times, hopefully not too much of the machines are failing, but as you gather more data, then you can optimize for the future stages, because you know exactly what are the ultimate success for overall of this continuous decision model. So continuous decision model takes into account exceptions and interruptions and uncertainties.
Okay.
Because it's event-driven, right?
It's event-driven, and it's a sequential decision model architecture.
Yeah, no, I still, I mean, maybe there's other examples that are not necessarily event-driven, although, but yeah, okay, thank you.
No worries.
Alex, it's extremely important questions. They always discussed in optimization conferences, and the Maynolf gave you a few good examples about these locations of warehouses, but there are no one-fit-all solution for this. It's always very problem specific and always requires a smart human in the loop.
No, agreed.
Okay. Anyway, and I think, Denis, do you want to make a comment or we can continue? Okay, probably already addressed. Okay, go ahead then. Denis?
Can you hear me?
Yes.
Oh, okay, sorry.
We don't see
yeah,
you, but we can hear you.
Okay. So it was more a comment that a lot of the construct of the continuous decision model are addressed and certainly tackled in CMMN. So I was wondering if you looked at that, because
Correct.
the notion of stage, the notion of event condition action, the notion of state machine that overreach and look at how things are progressing between stage are all basic construct of CMMN. So I was wondering if there are particular things that the continuous decision model add that are not in those constructs.
Absolutely right, Dennis. So one of the areas that we look at the CMMN, we look at before building the continuous model was looking at the CMMN. So it combines multiple different things that CMMN does not necessarily provide at very ease, and you need to build systems around it. For example, the optimization at 2 level for the overall journey plus the decision in the moment. And then CMMN does the handling of the cases based on certain conditions. But in order to do very detailed control of those cases, we combined the concept of CMMN with the state machine that you already mentioned. But plus, if you're familiar with the concept of the state machine in the UML, how they transition in and out happens, and the state's conditions are very tied to the events incoming and transition out and transitioning. There are many conditions that are not necessarily built into the CMMN. So as part of that, combining UML, state machine, CMMN, and optimization, it became the continuous decision model.
Okay, thank you very much, Arash. You brought a lot of very interesting and important questions, and I just would add that in more modern environment, when we talk about continuous decision modeling, we cannot ignore agentic AI, because orchestration logic always deals with state machines, and it can be event-driven and with long-running decision services. Or in this case, it would be decision agents, and hopefully that would be next year presented in much more concrete way. Thank you very much. Very good presentation.
Thank you, everyone. Thanks for having me. Cheers.